Good morning, friends. Welcome to Joy of Life once again. So, today we are back with another medium level problem from Leetcode. The problem number is 300. It says longest increasing subsequence. It's a very common problem. So, it says given an integer array nums, return the length of the longest strictly increasing subsequence. So, it says strictly increasing subsequence. A subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order of the remaining elements. For example, 3627 is a subsequence of um the array 0316227, and we are given with some of the examples. So we have seen the definition of a subsequence, so let's understand it in a little more details. So let me create the array for you first. So over here, as we know that any contiguous part, we call it is a subarray. So all subarrays are also subsequences. So the difference between subarray and subsequence is, in a subarray the element has to be contiguous, or in other words, if I draw a line, the line should not be broken, it should be continuous. Wherein in a subsequence the line can be broken. So I can consider these. So 033 and 622. So 03 and 622 as a subsequence. But remember, the order is important. We cannot change the order. We cannot say that 32602 is a subsequence. So here we have changed the order. So the order remains to be as is. The order cannot be changed, but we can take several portions of the array in order to come up with a subsequence. So here in the example, as we see 10, 9, 2, 5, 3, 7, 1, 0, 1, 18. So there are many strictly increasing. So when it says strictly increasing, also we need to understand that this is something which is strictly increasing. This is, whereas this is not. So if I put a graph over here, so 1 will be like this, then 2 is here, then 2 remains same, and then comes the 4. So this part creates a straight line. So this is not strictly increasing. So strictly increasing, the graph has to be like this. This problem comes with different flavor, that it could be strictly decreasing as well, and so on. But all of them have the similar kind of solution. So this is the problem. So as we see here, that the strictly increasing part that we see here is 257101. So you can see here 257101. Here everything, all the elements next to the element is increasing. So 2 to 5 is increased, 5 to 7 is increased, 7 to 101 is increased. There are many other increasing sequence as well. For example, 37101 is also a increasing sequence, strictly increasing sequence, but here we see that the length, it is not the longest. It has 3 and this has 4. So our answer over here is 4. So this is all about the problem, and we are going to look at the solution. And as I always say that before you look at the solution, do give it a try yourself. You can pause the video and then you can resume from here, and we are going to look at the solution. So here I have taken the array from the example given over here. So this is the array that we'll be using in order to see how it can be done. So this is a classic example for a dynamic programming problem. So we are going to use dynamic programming in order to come up with the solution. So the solution is pretty simple. So we are going to construct our dynamic programming table, which we will call DP table, but you can give it any other name that you wish to. And we will see how that the array can be used in order to come up with the solution. So we have created a DP array of the same size. As you can see, it is of the same size as the nums array, and we are going to come up with the solution. So initially, let's consider all the values to be 1 in the DP table. Yeah, so we have filled up the DP table with 1. And why we are taking 1 and not any other value? So I could say over here that the element 10. So before finding the subarray, that it itself is of size 1, and he is the longest subsequence. He is the longest increasing subsequence. So he is not considering any elements prior to it or any element next to it. He is just consider himself and thinking himself to be the largest one. Similarly, if we say for any other element, say for 5, 5 is also not considering any elements prior to it or any element next to it, and he is considering himself to be the longest increasing subsequence. So we know that every element can be a longest increasing subsequence because I am not considering any elements before me or after me. So I am just considering myself, and my answer is 1. So we are going to traverse through this entire list, and every point we are going to update the result, and also we are going to keep a track of what is the max that we are getting. Okay, so what I am going to do is, so as you know, the DP table, it answers, it has an answer at every cell. So what is the answer over here? Let's say the answer over here is, if I have a subarray, if I have an array of size 3, that is including just the element 10, 9, and 2, what is the longest increasing subsequence? Similarly, what is the answer over here? So if I have an array of 6 elements, what is the longest increasing subsequence over here? So till here we will find the answer, and we need to see where in all these cells that we have calculated, where can we get our max. So whatever max value we get out of it, we are going to store it, and that will be our return. Okay, so coming back to the problem again. So what we are going to do for each element, so let's say we are traversing the, so for each element I, we are going to check from 0 to I minus 1 and see what we can extend. So we will slowly see how this will come to effect. So what happens is, so let's say I is 0 now. So first let me create the table for you so that you have a better visualization. So I've created the table for you. So there are 7 indexes over here: 0, 1, 2, 5, 6, and 7. And the I will start from 0 and it will go up to 7. And for each of the elements, so when I is 0, uh, so let me put it over here. So when I is 0, j can have value which is null. We cannot consider j because the condition says that for my first loop, so as you can see from here, so my first loop will start from I equals to 0, I less than nums dot length, and it will increment. And what happens in the subsequent loop is, for j, which is my index, that is starting and going, starting from I minus 1, starting from I minus 1 and going, it should be greater than equals to 0, and j minus minus. Or it could be the other way around also. It doesn't matter that you are going from this side to this side or this side to this side. It is all the same. Okay, so we are going to fill up the table now. So initially I is at the index 0, and j could not have any value over here. So what we are going to do is we are going to copy the same value uh, from the above row. So to denote that, what I'll do is I'll just put a mark like this, that we are copying it from the above row. So when I is 0 means we have already got the value, the best value if the subarray is of size 0. So that means when I have only one element, array of size 1 and the value is 10, at that in that case my longest increasing subsequence would be 1, and that's what we already have, and that's what we are copying from the above cell, right? So now we are going to increment our I to 1. So I comes over here and j starts from 0 and comes till I minus 1. So basically what we are doing over here is we are trying to find the best value for this cell. And we already know the best value for this cell, which is nothing but 1. So I'm going to just denote it that we are getting the best value from here, from above. So we are going to check for this value. So at I equals to 1 and j equals to 0, we are going to see is I greater than j. And we see that it is not. So we are not going to update this value and j increments. So when j increments, this loop terminates, and what happens is we continue to have the same value, which is 1. And the rest all values is same as the above row. So for easier understanding, let's not put this down mark for the elements that we are processing. So let me put the actual value for them, which is 1. Now we are here to calculate the value for this cell, because for this j, there was only one index possible for j, and we are done with that, which is 0. So now let me update my counters. So I comes here and j comes here. So we continue to check. So these values will be same as above, and we are going to find the value for this cell, the cell over here. So we see that I is not greater than j, and j moves on, and I is still not greater than j. So what we do is we copy the value from the above cell. So basically, not a copy, we do not update ourselves. So we continue to have the value that we have, and these all remains the same, unchanged from the above. Now, again, the I is incremented. Now I goes to the next index, which is 3. So having said that, this means that we are going to find the value for this cell. And we copy, we already have, we know the value of the previous cell. So here again, j starts from here, and we see that I is not greater than j. J increments, I is still not greater than j. Then j comes here, where we see that I is better than j. So that means we can extend this array, and this will be my new longest increasing subarray. So I is currently having a value of 1, and j is also having a value of 1. So I can extend myself. So it becomes 2. So I am going to get the best result for. So basically, what we have already computed the value over here for this cell, which is 1. And what does that suggest? That suggests that that is the best result that I can get if my subarray ends there, or if my array ends there. And my current value is greater than that value. So that means I can extend that value. So I add, or I append myself to that subarray. So 5 gets appended to 2 and becomes a new subarray of size 2, which is 2 and 5. The two elements 2 and 5. So my answer changes over here, and it becomes, so this becomes a 2. And we copy the values. So these values we are not considering, not even touching, so they remain unchanged. I comes to 3, and j starts from here. So having said that, we are trying to look for the best result that we can get here. And let's copy the previous results that we have, that is 1, 1, 1, and 2. So j is not, I is not greater than j. J increments, still I is not greater than j. I comes here, j comes here, and we see that I is greater than j. And that means that we can append ourselves to the result. So the j value at j is 1 and my value is also 1. So we get a 1 plus 1, 2. And since we get a value which is better than what I have currently, I just update myself to 2. J moves on and we see that 5 is not, 3 is not greater than 5. So we are not updating anything over here. And the other values remains unchanged. I moves on to 7. So that means we are, let's get the value from the above cell. We are trying to find the value for this cell. So what happens over here? It does the same thing. I'll go a little faster this time because I think you got the idea what I am trying over here. So let me put J. So it's not true. This is also not true. So here I see that I can extend myself and get a value of 2. Again, it is true, and I see that the current value is 2 over here, uh, right? And the value at 5 is also 2. So 2 plus 1, we can get a 3 over here. We can improve ourselves further. So we change this value to 3. I moves on, J moves on, and again we see that we can get a value of 3. So we don't change anything and we copy the value from the above row, the remaining value for our table. But in case of array, we are not going to touch anything. So you can see here till J, the longest increasing subsequence that we can consider is 2, 5, 7. This is the longest increasing subsequence. So I moves on, I comes to 101 and J at 10. So let me copy the value and we are trying to look for the value at the cell, this cell. So again, can I extend 101? Yes, I can definitely extend. So the value there, what the value there is 1 and what we can do is we can append ourselves and get a 2. J moves on to 9 and again 1 plus 1 we can get is a 2. So we move on, we come here, we can extend. The best value that we can get is a 2, which is already at our value is already 2, so we extend. Coming at 5 we can see that we can get a better value which is 3. The value at 5 is 2 and my own value I can extend and get a 3, and so I update, I move on. Here also you can see that we can get a value of 3, so which is not better than what I have. I extend. At J I can see a value of 3 and if I append myself to it I get a value which is 4. So I go ahead and update my result. So a subarray ending at the index 6, the best value that I can get is 4, and which is 2, 5, 7 and 101. I moves on to the last index, starts from J. I see, let me copy the value first. We are looking for the value at the very last cell. So what I can see is that I can update the value. Um, I can get a 2 if I extend. J moves on. Again, I see I can get a 2. J moves on. Again, I see I can get a 2, which is not better than what I have. J moves on to 5. Here I can see that I can get a value of 3. So I update myself with a 3. J moves on. And again, we see that we can get a value of 3. Moves on. And we see that now we can improve ourselves with 4. So we are going to update the value and put a 4 over here. So the value at J was 3 and my own value 4, and then J moves on. Now the condition 18 is not greater than 101, so this loop terminates. And at the end we can see that our max is 4, and these are the two subarrays that is possible, 2, 5, 7 and 18 or 2, 5, 7 and 101. That's why we got two 4s over here. So this is how the entire algorithm works, and this is how we are getting the result at every cell and coming up with the solution. So we will quickly look at the code. So what we are going to do is first we are going to put some checks, normal checks. Nums dot length is 0. In that case, I know that I can't do anything, so I'll just read. Otherwise, what we are going to do, we are going to create an array of the same size. And what we are going to do is now we are going to fill up this table. Is I'm going to put for, and I'm just going to put a normal traversal logic over here. And so j starts from 0 and j less than nums dot, sorry, j less than I. And you're going to do a j plus plus. So every time before we update a cell, what we are going to do is we are going to put dp.i is equals to 1, because if you remember our initial state, we have all the elements as 1. So when we are going to process a particular cell, we are going to fill it with 1, and then we are going to put the logic in place that we want. So what is the logic that we are going to put? It's very simple, that in order to extend my result, my nums of I should be greater than nums of j, right? That's the only scenario wherein I can update my result. That's what we have also seen at every point. So what we are going to do is we are going to not only the value that we will get out of that cell. So this has to be better than the result that we have. In that case only we are going to update our result, right? And we are also going to so return a result, right? So let me put red equals to 0. So this is what we are going to return, and we are going to check that we have received anything better than what I have currently or not. So this will track down that what is the best value that I can get. Okay, so this is the entire logic for the same. So let's run it and see. So it has been accepted. So let's do a submit and see for a broader range of test cases how it goes. So it might happen that we never uh, enter into this loop. So what I'll do is I'll initialize red with 1 rather than 0. So we can see for a test case like 7777, it won't ever enter this condition. So my default return type should be 1, which is the size of a single element. So yeah, it has been accepted, and it looks okay, though you can think about some optimizations and make it better. The main intention again for me is to give you the idea. I hope I was able to convey my idea through the table of how things are generally gradually we are coming up to the results, how we are forming the DP table and coming up with the answer. And do let me know your thoughts about the video. Do comment, do subscribe if you haven't done so. Do share, like with your friends. And thank you for all your support. Thank you for watching the video. Have a great weekend. See you soon. Bye bye.